We are going to solve one question from mensuration from volume and surface area of solids. Okay, where water is flowing in a canal. Okay, so the canal is having some cross section. Okay, through which the water is draining out. So it's 6 meter wide and 1.5 meter deep. Okay, so it's 6 meter wide and 1.5 meter deep. So the two edges are, one is 6 meter and another is 1.5 meter. This is the section of the cross section of the canal through which the water is coming out. Okay, through which the water is coming out, and this water is going to irrigate in a field. Okay, in a field. So the question is that water in a canal 6 meter wide, 1.5 meter deep is flowing with a speed of 10 kilometer per hour. So the speed of water, so water speed is given to you as 10 kilometer per hour. It's 10 kilometer per hour, right? Now what else data is given to you into the question? How much area will it irrigate in 30 minutes if 8 centimeter standing water is required? So this water is coming and this canal is like this. Okay, this is a canal. This canal is like this, and through this canal the water is coming, and this water is going to irrigate on a field. Okay, so the field is like this. Let us say this is the field to be irrigated, right? This field to be irrigated. This is the irrigation field. That means which need to be irrigated. Now into this question it has been asked that how much area will it irrigate in 30 minutes. So the time given to you is 30 minutes. 30 minutes, right? And the speed of water flow is 10 kilometer per hour, right? Now if 8 centimeter standing water is required, that means the water which need to be kept standing into the field is 8 centimeter. So it will be just, the paddy crops, when it put into the field, it is holding some water inside it. Okay, so let us say this is the standing level of water. This is 8 centimeter, which can be said as 0.08 meter. So this level of water need to be kept standing into the field, right? So you can see the area of this field, the area of this field can be A, right? It can be A. Now it has been asked that if 8 centimeter of standing water is required into this field, right? This is entire water till a height of 8 centimeter, right? Now how much area will it irrigate? So it will be just, this field will be looking like a cuboid whose L, B and H are given, but LB is nothing but area. So this area multiplied by this height of water which need to be standing into the field, that is 0.08 meter. This will give you the volume of water. This will give you the volume of water, right? So this volume of water need to be equated with what? This need to be equated with this cross section of the canal, 1.5 into 6 meter, plus the water which is flowing or which is standing into this canal for 30 minutes with a speed of 10 kilometer per hour, right? So the total water in canal, water in canal can be find out with the speed. You can see the speed given to is 10 kilometer per hour. So it is just need to be converted into meter. So 10 into 1000, because 1 kilometer is 1000. So 10 into 1000 meter divided by this hour. That means it is 10 kilometer per hour. So this is the speed in meter per hour. So instead of hour, divided by 60, so that it will be in minutes, right? This is the water flowing per minute, right? 0 0 can be cancelled out, so we can say 1000 by 6 meter of water per minute will be standing into the canal, and this water need to be calculated for 30 minutes, right? So this meter of water, 1000 by 6 meter of water multiplied with this 30 minutes, because this is the water for 1 minute, right? So 1000 into 30 by 6, right? 1000 into 30 by 6 is the water standing over here. This one, this will give you the length of water here. 1000 by 6 into 30 meter, right? Now let me squeeze a little. Yes. Now this will give you some volume, right? This means this will give you only the length, but this will be converted into a volume only when this cross section of the canal will be multiplied 1.5 and 6. So this will multiplied with 1.5 multiplied with 6. So this will give you meter, right? So just solve it. You will get the area of the area of the field which will be irrigated through the water which is flowing at 10 kilometer per hour, and water is kept on flowing for 30 minutes. I hope you understand this concept, right? Because this will be the volume of the cuboid for the farming field, irrigation field, right? And this will, with this speed for 30 minutes we get the height, this one. And L and B is already given to you into the question, because the cross section of the mouth of the canal is 6 meter and 1.5 meter multiplied with this height 1000 by 6 in for 30 minutes. This will give you the section of the cuboid or the water which will be accumulated across the canal, okay? And this water will be coming to the field, right? Now just solve it to get the value of A. So can be A can be written as, here 6 and 6 will be cancelled out into the RHS, and we have 15 1000 into 30, 1000 into 30 by 0.08, this one, right? 0.08 multiplied by this 1.5 is also into the numerator, 1000 into 30 into 1.5 by 0.08, right? Just this need to be solved, right? Now when you solve it, this will give you the area of the field. Now here you can see this 208 will give you 10 power 3, and this 2 zeros from here, so this will be 10000, 5 zeros over here multiplied with 38 15 into 30. This will, when you replace this decimal from 1.5, 10 will be coming over here, and this 10 will be deducting this 0. Now this will be 45 by 8 meter square. This is the area of the field which will be irrigated, right? Now let us solve it before closing. We'll just arrive on the final answer. So 45 by 8, that will be coming as, first write these 5 zeros over here, then 8 6 48, no 8 7 8 8 into 5 40, carry 5, right? Decimal 8 6 48, carry 2, 8 2 16, carry 4, 8 5 20. So it will be 5.625 into 10 power 5 meter square of area, which will be irrigated, right? Okay. Now here you can see, 5.625 multiplied by, you can see, if you replace this decimal, we have 1000 into the denominator, and this will cancel these 1 2 3 zeros over here, right? And we have 5 6 2 500 meter square, 562,500 meter square of area, which will be irrigated. Hi Atlant, hello my dear friend. Yes, so this will be the area, which will be irrigated, 562,500, right? So the area which is irrigated is 562,500 of meter square. This much of meter square, right? And this is the area which is irrigated. This is solved, students. Yes, hi Atlant. I have a school soon. Oh, I am primary school. Yeah, great. Perfectly fine. Yes, yes. Oh, then you need to go to school on time, isn't it? You can connect it later on. Thank you. So students, in this way we can solve such questions of volume and area. Yeah, Atlant, thank you for joining the session. And if you find it useful, you can be connected. And yes, just try to solve these questions though in primary school, but the concept underlying over here is very understandable concept, and you should not think that you are in primary or middle or senior secondary. Okay, you can easily understand. Yes, you are a small YouTuber also. That's great. That's great. Atlan. Perfect. Perfect. Yeah. You can share me. I will see what is your details. 15. Great. Great. I will always say all the best from my side. Okay. Thank you, Atlan. Thank you. And just be connected. And I like your participation into the today's session. Okay. And I think in this way we can easily solve such question. So let me read out the question again. Water in a canal 6 by 6 meter and wide and 1.5 meter deep is flowing with a speed of 10 kilometer per hour. Here you can see how much area will it irrigate in 30 minutes if 8 centimeter of standing water is required. So here you can see water is turning into the canal with the rate of 10 km per hour for 30 minutes. We calculated that 1000 by 6 into 30. This is per minute into 30 minutes. This will give you this length of the water standing into the canal, right? LB is already known to us. So LB into H. So we just equated the volume of water into the field with volume of water into the pipe, into the canal. So when you equated it, you get the value of A, that is area. And area which need to be irrigated is 562,500 meter square of area, which need to be irrigated, which will be irrigated when the water will be flowing through the canal at a speed of 10 km per hour, and when it will flow for 30 minutes, right students? So thank you so much for watching, my dear friends, my dear students. Just be connected, and we will certainly come up with separate sessions soon. US Jamaican, no, great Atlan. Yeah, happy to see you over here into the class. Yes, it's a very nice country, I know. Yes, yes, yes. Yeah, Atlan. Perfectly fine. I hope you understand today's session or not. If you want, I will explain it again. Okay. What is the underlying concept over here? Water is flowing at a rate at the speed of 10 kilometer per hour, and the dimensions which is given to us is in meter. So convert this kilometer into meter, and we just simply multiplied with 1000, right? and we just calculated its the speed is given per hour. We just converted into per minute, and that's why this hour into the denominator is converted into 60 minutes. So this will give you 1000 by 6 meter of water flowing per minute, and this water is flowing for 30 minutes. So 30 will be multiplied with per minute of flow of water from this canal. So this will give you kind of just you can see just like a cuboid, a water of cuboid of water, right, like this. And this will be flowing into the into a land which is having some area, okay, and the water standing over on it till a height of 0.8. So you can see here also a cuboid will be formed and water will be standing into it, right? So you just equate the area of this field multiplied with this height of a standing water. This will give you a volume of water in the field multiplied with volume of this standing water into the into the canal, right? We just equated it and find out the value of area, right? So the area will be 562,500 meters square. You understand that land? Thank you so much. I know you are genius people. Yeah, great country, great guys, great my dear friend. So thank you so much for being connected. And yes, let me know if any query I can come up with separate session, and any query you can put up into the chat. I will come up. Okay. So if it's your school time, then yes, it's your decision. How much time you are left within your hand and how to carry on. Hi DT Extra, how are you? Watch that. Next one. Oh, you want more questions to be solved? Oh, perfectly fine. That means you are having certain time with your hand, right? In your hand. Okay. Let me take some different question. Okay. A spherical glass vessel has a cylindrical neck. A spherical glass vessel is there with you. Okay. Yes. So let me take this question. This is question number 2 for today's session. A spherical glass vessel has a cylindrical neck. That means a spherical vessel with a cylindrical neck. That means it's just like a flask. It's a cylindrical neck, okay, and then a spherical glass vessel like this, right? Right? 94 divided by 3, please, at land. Or you want me to divide it? Yeah, we'll take up this question separately at land, EDT. After this, allow me to solve this question, please. So here a spherical glass vessel has a cylindrical neck. So this is the portion of neck. As you demanded, let me solve this question first. So this portion is the neck which is into the shape of a cylinder. You can see a cylindrical neck, right? Now here it's 7 centimeter long. So 7 centimeter is the height of this neck. This is 7, right? Now, and 4 centimeter is the diameter. So we can say that yes, this is the radius, which is diameter by 2, 4 by 2, which is coming as 2 centimeter. This is the value of r, the radius, right? Now the diameter of the spherical part is 21 centimeter, and this spherical part is having diameter of, this is having a diameter of 21 centimeter, right? Find the quantity of water it can hold. Okay, simple student, simple. It's very simple. You can see, just calculate the volume of this sphere. What is the volume of this sphere? This is a spherical shape. Okay, so volume of a sphere, 4 by 3 pi r cube. And what is the value of r? If diameter is 21, R will be 21 by 2 and this cube of this, right? And if water is filled up till the neck, till the bottom, then what we will do, just add this volume of the sphere plus volume of this cylinder. What is the volume of this cylindrical neck? What is the volume of cylinder? You remember? Pi r square h, right? So just write pi, and what is the radius over here? 4 was the diameter for the neck. So the radius which we have calculated over here is 2, right? So it will be pi into 4 by 2, which is 2, pi r square into h, and this 7 is the height of this cylindrical neck. Here you can see this is the height multiplied with 7, right? Just solve it, okay? You will get your answer. This much of centimeter cube is the water content. Water is basically, it's the volume. Water can be measured in the form of its volume, okay? So the volume of water which is contained, you can just solve it and this will give you the answer, right? It's very simple. Heartland. Oh, you are putting some hard questions to me. Roblox, I don't know, my dear friend. So, yeah, be connected and let us see for with some separate questions and good question into the next session, students. My dear friend, Atlant, EDT extra 94 divided by 3. 94 divided by 3, you want me to solve? Is this 313, 3, 9, 4 will be balanced out, okay? And here just 3, 1, 3, carry 1, then 3 bar, right? I think this was your question. Okay, so I think I did not disappointed you. I also solved that division, right? Be connected, students. Take care. Bye bye. See you soon with a separate session.